Hey everyone, and welcome. Today, we are going on a quest for something, well, something pretty mind-bending. We're looking for a single, universal grammar. But not for language. We're talking about a grammar for information itself. From the way neurons fire in your brain to how ideas spread across the entire internet. Let's dive in.
So I want you to just forget about English or Spanish for a second. What if there were a set of fundamental rules that govern how everything connects? How an opinion spreads on social media, how signals travel through a neural network, how data moves through a computer program? I mean, what would a grammar for reality itself even look like?
Let's start with an analogy we all get. Language, grammar, right? It has rules, nouns, verbs, syntax that let us combine words into sentences that actually mean something. Well, an information grammar takes that exact same idea and blows it up to cover, well, everything. It's about finding the universal principles for how any kind of information gets organized and shared.
So how in the world do you even begin to write a grammar for reality? You can't just guess, you have to build it from the absolute ground up, with the same kind of rigor you'd use in mathematics.
It all starts with something called the axiomatic method. Now, this is just a way of thinking where you begin with a tiny handful of core truths, or axioms. These are ideas that are so fundamental, so self-evident, you just accept them. They're the absolute bedrock of your entire system.
And from that bedrock, you build everything else. You start with those basic axioms, use logic to build rules on top of them. And then, and this is the really amazing part, every single complex behavior of the system, no matter how wild, can be traced right back to those first few simple truths.
The key to all of this is abstraction. We're not getting bogged down in the details of one specific system. No, we are zooming way out to find the deep patterns that repeat themselves everywhere. This is what lets us build a single model that can be used across tons of different fields.
Now, if you're going to build a universal grammar, you obviously need a language to write it in. And to describe universal patterns, mathematicians have come up with an incredibly powerful one.
That language is called category theory. The source material actually calls it the primary abstract language of universal patterns, which, you gotta admit, is a pretty bold claim. You should think of it less like a specific subject and more like a powerful new lens for seeing the world. You see, category theory completely shifts your focus. It doesn't really care about what things are, the objects themselves. It cares about how they connect, how they relate, and how they transform into one another. This makes it the perfect language for our grammar. It's kind of like a universal translator that can find the same core structure in a piece of software and in a biological cell. Okay, so we have our method for building and we have our language for writing, but how do we actually use them to see information moving around? How do we analyze the flow?
One of the coolest tools for this is something called profunctor optics. Yeah, I know, it's a mouthful, but the metaphor is perfect. Think of it like a set of mathematical lenses that let us zoom in and track exactly how a piece of data moves through all the different parts of a really complex system.
This lens really helps us apply a core engineering principle called compositionality. It's this simple but powerful idea that you can understand a massive, complicated system by breaking it down into its smallest pieces, understanding each one, and then seeing how the rules let them fit back together. Profunctor optics gives us the mathematical framework to do just that. And the kinds of systems we can model with this are just incredibly diverse. I mean, think about it. For social networks, we can use this grammar to precisely map how an opinion flows from one person to the next. Or we can apply it to AI to better understand the web of connections inside a neural network. It even helps us untangle the logic of massive, distributed computer systems.
And the toolbox for this grammar is just getting bigger and bigger. For instance, there's a concept called causal graphs that lets us create a map of how a system changes over time, basically showing us the chain of cause and effect. Other tools even give us a way to measure uncertainty when the information we're dealing with is vague or incomplete.
Okay, I know this all seems very abstract, so let's zoom back out. Why are we going to all this trouble to create a universal grammar? What's the real-world payoff here?
While the power of this approach is really all about scope, instead of building a totally unique model from scratch for every single problem, which is super inefficient, a universal metamodel gives us a powerful, reusable framework. It lets us apply the same deep principles to any system where information flows, which saves a ton of time and helps us see connections we would have totally missed otherwise.
And this leads to some really tangible results. This grammar can help us build more robust, reliable software. It can help us create better models of how ideas and opinions spread online. We can use it to design smarter, more efficient AI, and even understand how complex biological systems, like our own bodies, manage to regulate themselves. It's about giving us the tools to engineer systems that are way more intelligent and resilient.
At the end of the day, this whole thing isn't just some abstract theory. It's about giving the entire field of information systems theory a rock-solid mathematical foundation. It's about transforming it from just a collection of specific models into a rigorous predictive science that's built on verifiable universal truths.
So this leaves us with a pretty fascinating final thought. For centuries, mastering the grammar of language has allowed us to create these incredible stories, poems, and philosophies. So what happens if we can truly master the universal grammar of information? What incredible new realities will we be able to write into existence?